Welcome to the Explainer. Today, we're going to talk about something that is absolutely essential for making software that doesn't, well, break. It's called exception handling, and it's the invisible hero that keeps your favorite apps from crashing. So let's start with a moment we've all been through. You're right in the middle of doing something important, maybe typing a long email, or you're about to beat that final boss in a game, and then, poof, the app just vanishes. Gone. No warning, nothing. It's super frustrating, right? Well, that exact moment is what this is all about. And really, this is the fork in the road we're looking at today. On one side, something unexpected happens and the whole program just crashes and burns. But on the other side, that same exact event happens, but this time you get a controlled response. Maybe a helpful error message pops up, or it gives you a chance to save your work. It's the difference between total disaster and a graceful recovery. So, to really get why the solution is so smart, we first have to understand the problem. What actually causes a perfectly good program to suddenly, well, go bad? It's usually not some catastrophic bug in the code itself. Most of the time, it's something from the outside world the program just wasn't ready for. Maybe a user types hello where a number should be, or a file it needs to read suddenly isn't there. Your internet connection drops. The computer just plain runs out of memory. Or, yeah, even something as simple as a math problem that's impossible, like trying to divide by 0. Okay, that might sound a little intense, but it really drives home how important this is in the software world. If you don't plan for these kinds of errors, if you don't anticipate that things can and will go wrong, it's not just a small mistake. It's seen as a pretty fundamental gap in how you build things. So what's the fix for all this chaos? Well, it's a really elegant and powerful concept called an exception. The best way to think about an exception is like a formal alert. It's the program raising its hand and saying, hey, something's not right here. Instead of just crashing, it sends out this special signal, the exception, to let the rest of the system know that the plan has changed and it can't continue on its normal path. Now here's where it gets really cool. This error signal isn't just some generic warning light. In modern programming, an exception is actually a smart object. And what that means is it carries a ton of useful information with it. It's not just saying something went wrong. It's saying a file was not found and it happened on line 52 of this specific script. It's like a detailed incident report. Okay, so we have these smart little error reports flying around. How do programmers actually use them to stop the app from crashing? Well, they build a safety net. It all boils down to a simple 3-step drill. First, you tell the program to try a piece of code that you know might be a little risky. Second, you set up a net to catch a very specific kind of error if it happens. And third, you have a finally step that runs no matter what, just to clean things up. It's a structure that prepares you for anything. And here are the actual tools in the toolkit. The try block is like the high-wire act. That's where the dangerous stuff happens. The catch block is the safety net waiting right below, ready to grab the performer if they fall. Then you've got throw, which lets a programmer create their own error signal on purpose. And finally, that's the cleanup crew that comes in afterwards to make sure everything is put away, whether the trick succeeded or not. So let's get back to this idea of exceptions being objects, because that concept is what makes this whole system so flexible and powerful. Because they're objects, we can organize them into a kind of family tree. You've got your big general exception at the very top, but underneath it you have more specific types. An I/O exception is for problems with files or the network. An arithmetic exception is for, you guessed it, math errors. This hierarchy is super, super useful. So why does this family tree matter so much? It's because of a programming principle called polymorphism. It basically means you can choose how specific you want your safety net to be. You can set up a tiny net that will only catch an arithmetic exception, or you can set up a much bigger net to catch any kind of I/O exception, or an even bigger one to catch absolutely any exception that comes along. It gives you incredible control. Okay, so we've got the tools, we get the theory. What does this look like in the real world? How do you go from just knowing about this stuff to actually handling errors like a pro? Well, there are a few key rules of thumb. First, you don't use exceptions for just anything. They're for truly exceptional events. Second, you always use that finally block to clean up resources like files or network connections. Third, you write error messages that actually help the user understand what's wrong. And finally, if you have a really unique problem, you can even create your very own custom exception types. And you see the results of this everywhere.
every day. When your app says network connection lost instead of just crashing, that's exception handling. When a website tells you please enter a valid email address, that's handling bad user input. It's the silent engine that makes software feel stable and user-friendly, even when the world around it is a little bit messy. So, at the end of the day, this is the question every single developer has to face. Errors are going to happen. It's not a possibility, it's a guarantee. The choice isn't about whether your code will ever fail. The choice is, what will it do when it fails? Will it be fragile and just shatter, or will it be robust, able to handle the unexpected and keep on going? That's the difference exception handling makes.